So this L'Hopital rule works really great, but it only works if you have the forms, the indeterminate forms, 0 over 0 or infinity over infinity. So there's other indeterminate forms like 0 to the 0, 1 to the infinity, infinity minus infinity, 0 times infinity, or infinity to 0. So we can still use this rule if we get one of these, but first we have to change it so that it looks a little different. So if we plug in this, we would get 0 times infinity. And so that's an indeterminate form, but it's not a fraction. So we need to be able to make this a fraction before we try to apply L'Hopital. So that could be an easy way to write it as a fraction. Let's use the L'Hopital rule. Take the derivative of the top, derivative of the bottom. Now let's try to evaluate the limit. So we'd get some sort of infinity over infinity. Well, that doesn't work. Maybe we could try it one more time. See, maybe we're in a loop. So we get what, negative? Actually, let's just rewrite this. Limit as x approaches infinity. That's 1 over 2 square root of x e to the x, because now we don't have the top and the bottom we're worrying about. Infinity. The bottom is going to get infinitely big. So that's going to go towards 0. So that wasn't so bad. And now we're going to be careful with our one-sided limits here. Limit of that would be some sort of infinity minus an infinity, which it is an indeterminate form, but it's not a fraction. So we need to make it a fraction. All right, so let's get a common denominator and combine those fractions. X minus 1 minus ln x over ln x times x minus 1. Let's try plugging in 1. 0 over 0. Okay, good. Take the derivative. 1 minus 1 over x over. All right, product rule. Well, maybe that'll work. Let's try. 0 over 0. Nope. All right, so I'm going to clean this up. We're going to multiply everything by x. So we get x minus 1 plus x ln x. Okay, I just rearranged it, so it's not like we're still going to be able to plug in anything. There we go. I want to more. Whoa, not that much. Okay. So let's try L'Hopital's rule again. 1, oh, that's good, over 1 plus product rule, ln x plus x times 1 over x, which is just 1, right? So I'm going to clean it up. You might not have to. 1 plus ln x plus 1. Plug in 1 from the right. Ln of x is approaching 0, so that ends up being 1 over 2, which I think was one of our first problems. Maybe not. I don't remember. Okay, on to the next one. Well, this looks a little different. Sometimes we need logs to come to our rescue. All right, so we're kind of going to think about this as maybe like log diff, since you guys are great at that, right? So we're going to set this equal to y, because we get 1 plus, and this is one of the problems we had in the beginning. So we'll finally figure out what that answer is. So 1 plus 2 over infinity to the infinity. So we have this 1 to the infinity type thing. All right, so what we're going to start out doing is taking the ln of both sides. And we can move that ln wherever we want. That's a property of limits. And so now I can use properties of logs. I can move that x to the front. Don't lose that ln of y. All right, so now if I try plugging it in, I get infinity times 0, which is good. Let's make it look like a fraction so we could try to use L'Hopital. Now, what do you want to move to the bottom, the x or the log? I think the x is a lot easier to move, so I'm going to move that, x to the -1. Okay, so take the derivative. 1 over 1 plus 2 over x times x. Sorry, I gotta clean that up. Times the derivative of the inside, which would be what? Negative 2x to the -2 over negative x to the -2. Well, look, we have a negative x to the -2 and a negative x to the -2. That's good. I'm going to keep writing, but I will end up erasing this. So the limit as x approaches infinity, and we get -2, no, we crossed out the negative. 2 over 1 plus 2 over x equals ln y. Plug in infinity, 2 over infinity, 0. 2 over 1 is 2. 2 equals ln y. E squared is y. Wow, what an exciting problem. All right, let's clear that out of there so we can work on the other one. Ooh, x to the x, that's exciting. So 0 to the 0, what is that? Well, in this case, let's find out. So I'm gonna go ahead and go to this. Well, I think it was this step here. Limit as x approaches 0. Okay, so ln, we're using ln here, equals ln of y. I need to write this as a fraction so I can use L'Hopital's rule. I can use L'Hopital's rule. 1 over x, negative 1 over x squared. If I multiply both by negative x squared, then I would get this. I would get what? X, negative x. So 0 equals ln y. E to the 0 equals y, which is 1. Yay! Okay, one last more one with logs here. If you plug it in, you get infinity to some sort of infinity. So we're going to take the ln of both sides. I really should show this step, but I'm sneaking through here. All right, so then I would move that to the front. Ln x equals ln y. I already have a fraction form. I'm just going to put it together so it looks more fractiony. Derivative. 1 over x over 1 equals ln y. Well, 1 over infinity is 0. E to the 0 equals y, and y equals 1. Again, neat. All right, last one. It's a fun one. If we take an integral from 1 to 1, we get 0, and on the bottom we get 0. So let's take the derivative of this using the fundamental theorem of calculus. The derivative of an integral, in this case, is cosine of x. The denominator will be 2x. Plug in 1. Cosine of 1 over 2. The end. And what a great thing to end on.